In our last lecture, we saw that an infinitely long wire carrying a current will create a magnetic field around it with a magnitude mu sub naught I over 2 pi r, direction determined by the right-hand rule. Last week, we learned that a magnetic field can exert a force on a current-carrying wire. If the direction of the magnetic force is perpendicular to the direction of the wire, then the force on that current-carrying wire is B times I times L. Now, a wire will not experience a force from the magnetic field that it produces, much like a charged particle will not experience a force from its own charge. However, if there are two parallel wires separated by a certain distance d, then we can use this formula for force, substituting this in for B, and we get the force between the two wires is equal to mu sub naught over 2 pi times I1 times I2 times L over D, where I1 and I2 are the currents in the two different wires. L is the length of the wire, and D is the distance between them. Now, the direction of this force will either be attractive or repulsive. If the two currents are going in the same direction, then it is an attractive force. If they are going in opposite directions, it is a repulsive force. Now, you might notice that we have started by assuming that the wires are infinitely long, and that the total amount of force depends on L. L is infinity, means force is infinity. In reality, no wire is actually infinite in length. They can be very, very, very long, but they do eventually terminate or loop back on themselves. In the context of this class, what we will usually see is that one wire is infinite and the other is finite, usually looping back in on itself, in which case we say the infinite wire produces the magnetic field, and we use the length of the wire segment. Option 2, instead of trying to find the force itself, we find the linear force density, or force per unit length. For that, we can take this formula, divide by L, and we get mu sub naught over 2 pi times I1 times I2 over D, which is a nice finite value.